Here we go again. Question number 5 into page 268. Find this shaded area. Here's the equation of the curve y equals square root of 4 minus 2x, and the limits, as you see, respecting to the x-axis, because we do only integration respecting to x, as we do that on differentiation as well. 0 to 2, and even respecting to y 0 to 2. But if you want to do respecting to y, you have to change the subject, which is not required. So y is equal to 4 minus 2x power of half. Now let's do the area. Area integration from 0 to 2 of 4 minus 2x power of half dx. Derivative of the expression that you have inside is negative 2, but the derivative is not given on the function. So you need to divide it by the derivative first, 1 over negative 2, then add the power by 1, half plus 1 is 3 over 2, dividing 3 over 2, and don't write plus c from 0 to 2. I'll cancel the 2 with the 2 in the denominator, because 3 over 2 times 2 will give you 6 over 2, which is equal to 3. You can't write the constant outside, 1 over negative 3. You can't write the 3 outside. Then replace 1's 2 and replace 1's 0. Don't say 0 will give you 0 here. 0 will not give you 0. 0 will give you something else, because you have an expression. So 4 minus 2 by 2 all to the power of 3 over 2, that will give you 0, minus 4 minus 2 by 0 all to the power of 3 over 2. Yes, negative 1 over 3. Now only negative sign is left inside 2 by the 0, 0. And then 4 to the power of 3 over 2. Let's do that using the calculator. 4 to the power of 3 over 2 is equal to 8. So it's negative 8. Negative by negative is positive. Then the answer is 8 over 3 square units. This is the value of the shaded area. Here we go again in question number 5 on the same question number 5c, the same exercise. It's required to find the shaded area. As you see, we have two parts of the shaded area, one of them from negative 2 to 0 and the other one from 3 to 4. So we're going to divide them into two parts. Area 1, which is started from negative 2 to 0, of f of x dx, and area 2, which is from 3 to 4, f of x dx. Integration from negative 2 to 0 of x minus 2 power of negative 2 minus 1 dx, and same thing from 3 to 4 of x minus 2 power of negative 2 minus 1 dx. Integration of x minus 2 power of negative 2, derivative of the expression that you have inside is 1. So you need to divide it by 1. So just directly add the power by 1 and divide it by the new power. Negative 2 plus 1 is negative 1 divided negative 1. And differentiation of 1 is x from negative 2 to 0. Same thing here. But the point is, as you see, these two shaded area are below x-axis. So you're supposed to add a negative sign before that. Or you change your answer from negative to positive, or using modulus because it's below x-axis. Same thing here. So let's write the same. This is negative, 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 negative here. X minus 2 power of negative 1 over negative 1 minus x from 3 to 4. I'll start with the 0 first. So 0 minus 2 power of negative 1 over negative 1 minus 0 minus, using negative 2, negative 2 minus 2 power of negative 1 over negative 1 minus negative 2. Keep the negative sign outside. For this part, negative 2 power of negative 1 is negative half. And negative half divided negative 1 is positive half, minus 0. Then minus negative 2 minus 2 is negative 4, which is quarter. negative quarter. Negative quarter divided negative 1 is quarter, and minus negative 2 is positive 2. Have minus 9 over 4. If you do that on the calculator, have minus 9 over 4, then the answer is negative 7 over 4. And you have a negative sign outside, so the answer is 7 over 4 square root. Or square root is square units. This is the value of the area 1. And at the end of the textbook, you'll find 1 and 3 over 4 square units, which is the same thing. So both of them right. For this part, remember you have a negative sign outside. So let's replace 4 first. 4 minus 2, power of negative 1 over negative 1 minus 4. Then minus, using 3. 3 minus 2, power of negative 1 over negative 1 minus 3. For the first part, 4 minus 2 is 2. 2 power of negative 1 is half, and half divided negative 1 is negative half. Negative half minus 4. Then 3 minus 2 is 1. 1 power of negative 1 is 1. Divided negative 1 is negative 1 minus 3. So negative, this is negative 9 over 2 now. Then negative 4, so it's plus 4. If you do that on the calculator, negative 9 over 2 plus 4, then the answer is negative half. So negative, negative half, and the answer is half square units. Question number 6 on the same exercise. Find the volume of the solid generated when the shaded area is rotated through 360 about the x-axis, then find the shaded area. So as you see, the limits from 0 to 2 of 1 over x plus 1 power of 1. We're going to find the area first. I told you the denominator has power 1. So you couldn't raise or move the denominator and change the sign of the power. So directly it's len. So it's len modulus of x plus 1 from 0 to 2. So len of 2 plus 1 minus len of 0 plus 1. Len 0 plus 1 is equal to 1. So len 1 cancelled, which is equal to 0. Then the answer is len 3 square units. This is the area. What about the volume? Volume, you're supposed to add pi when the volume generated through 360. So add pi, integration from 0 to 2, and you have to square the function. So 1 over x plus 1 all to the power of 2 dx. Now you can move the denominator by changing the sign of the power. So pi integration from 0 to 2, x plus 1 all to the power of negative 2 dx. How you did that? If you distribute the power, so 1 power of 2 will give you 1. 1 to the power of any number is 1. And then that denominator is x plus 1 power of 2. So when you move the denominator, you have to change the sign of the powers. Then that will give you x plus 1 power of negative 2. So keep the pi as it is. Integration is x plus 1 power of negative 1 divided negative 1. And don't write plus c from 0 to 2. Once you have to replace 2. So 2 plus 1 power of negative 1 over negative 1 minus 0 plus 1 power of negative 1 over negative 1. 3 power of negative 1 is 1 over 3, so it's negative 1 over 3. Then this is negative 1, so plus 1. Then the answer is 2 over 3 pi cubic units. Question number 10 on the same exercise. Find the area of the shaded region in part A, and part B find the volume. And the limit is received from 0 to 1. So area, integration from 0 to 1 of e power of 1 minus 2x dx. I told you derivative of the power first. Check the derivative of the power. Derivative of the power is negative 2, but it's not given. So you do 1 over negative 2, then integration of 1 minus 2x from 0 to 1. Once you have to replace 1 and once you have to replace 0. So e power of 1 minus 2 by 1 minus e power of 1 minus 2 by 0. Negative half, it's e power of negative 1 minus e power of 1. Negative half, 1 over e minus e. If you want to make common denominator, so the common denominator will be 2e. And remember, you have a negative sign outside. 1 times 1 is 1, and e times e is negative e squared. So this could be the answer, but the answer has to be positive. So we can enter the negative sign inside, so it's positive e squared minus 1 over 2e squared units. Find the volume of the solid generated when the shaded area is rotated through 360 about the x-axis. By the way, if you just back to this question and you just calculate this part again, you'll find it as positive. It's the same as this. It's not negative at all. So don't think to use the modulus at all, because that area is not below the x-axis, it's above the x-axis. Now volume, pi integration from 0 to 1 e power of 1 minus 2x power of 2 dx. So keep the pi as it is, integration from 0 to 1 e power of 2 minus 4x dx, because you're supposed to multiply the powers, not raise the power to the power, just multiplying the powers. Derivative of the power is negative 4, and negative 4 is not given, so 1 over negative 4 e power of 2 minus 4x from 0 to 1. Negative quarter e power of 2 minus 4 by 1 minus e power of 2 minus 4 by 0. Negative quarter, then e power of negative 2, because 2 minus 4 is negative 2, minus e power of 2. We're going to do the same thing that we did in the previous part. Negative quarter, 1 over e squared minus e squared over 1. Common denominator is 4e squared if you multiply the denominator. So 1 times 1 is 1. You remember you have a negative sign outside, so 1 minus e power of 4, or e power of 4 if you enter the negative sign, minus 1 over 4 e power of 2 cubic units, because this is volume. Question 12. On the same exercise, this diagram shows the curve y equals square root of 1 plus 2x. The curve meets x-axis at point A. This is the x-intercept. B is y-intercept, and the y-axis at the point B. The normal, this straight line is representing the normal to the curve at the point B, meets the x-axis at the point C. So this point is x-intercept of the normal only, not for the curve. It's required to do 4 things. The first part, find the coordinates of the points A and B. So as I told you, A is x-intercept, so you have to do y equals to 0 in the equation of the curve. So 0 equals root of 1 plus 2x. How did you remove the square root? By squaring of both sides. So square will cancel the square root. 0 equals 1 plus 2x. Then x is equal to negative half. So the coordinates of the point A, negative half and 0. For point B, which is x-intercept, which is y-intercept, so we have to replace x as 0. So by replacing x as 0, y equals to 1 plus 2 by 0, then y equals to 1. So the coordinates of the point B, 0 and 1. Now let's find the equation of the normal. Let's just back to the differentiation. So normally, differentiating this type of function, these types of functions, we have to change the radical into root into power, and then you have to use the chain rule. So y is equal to 1 plus 2x all to the power of half. Y dash is half 1 plus 2x all to the power of negative half times 2. Then it's 1 plus 2x power of negative half. Gradient of the tangent, remember this is point B, x and y. So 1 plus 2 by 0 power of negative half, which is equal to 1. So gradient of the normal is negative 1. Now let's do the equation. Y minus y1 equals mx minus x1. It's good practice and revising about that we did before in differentiation. Y minus 1 equals the gradient negative 1x minus 0. Move negative 1 to the other side. So y equals to negative x plus 1. This is the equation of the normal. Find the coordinates of the point C. So C, I told you in the previous part, C was the x-intercept of the normal. How did you find the x-intercept of the normal? So you replace y as 0, but in the equation of the normal. The equation of the normal is negative x plus 1. So 0 equals to negative x plus 1. Move 1 to the other side. We can move the negative x, so x is equal to 1, which means the coordinates of the point C, 1 and 0. Part D, find the area enclosed by the curve, the normal and the x-axis. Let's back to the question again. This is the question. So we have two parts, from A to 0 and 0 to C. 0 to C, this part is a right angle triangle, so let's call that area 1 and this is area 2. From A to 0, we're going to find that using area integration from A to 0, and then from area 2, it's area of triangle, which is half base height. This is the base and this is the height. Let's find area 1 first. Area 1 equals to integration. Point A has the coordinates negative half and 0. So the coordinates, this is not the coordinates, this is the limit from negative half to 0 of the function square root of 1 plus 2x dx. This is how to find area 1. And then area 2 is area of triangle half base height. So half times, I told you base is representing the x-intercept of the normal, which is 1, and the height representing the coordinates of the point B, which is 1 again. So half times 1 is equal to half squared unit. So we got the area 2. Now area 1, derivative of what you have inside is 2, but the 2 is not given. And remember, that square root is power half. So 1 over 2, you need to divide it by the derivative. Then add the power by 1. 1 plus 2x power of half plus 1 is 3 over 2, dividing 3 over 2 from negative half to 0. By multiplying 2 times 2 in the denominator, or half times 1 over 3 over 2 will give you 1 over 3. Now let's replace 0 first. 1 plus 2 by 0, power of 3 over 2, minus replacing half, 1 plus 2 by negative half, all to the power of 3 over 2. This part is 0 because negative 1 plus 1 is 0. Now only one part left. 1 plus 2 by 0, 0 times 1 is equal to 1 over 3. Therefore, the total area is equal to area 1 plus area 2. 1 over 3 plus 1 over 2 is equal to 5 over 6 square units. Last part of this question, it's required to find the volume of the shaded area when it's rotated through 360 about the x-axis. We have two parts of the volume. volume 1 and volume 2. Let's back to the question. This part using integration, normal integration, and this part we're going to do the volume of the cone. Volume 1, pi from negative half to 0, so squaring of the square root will cancel. Then you have only 1 plus 2x left. Integration of 1 is x, integration of 2 is 2x squared over 2. 2 will cancel 2. Once replacing 0 and once replacing negative half, so you're going to find at the end quarter pi. Volume 2 using cone, so radius is the distance from the origin to the point B, and height is the distance from origin to point C. So 1, both of them by the way 1, so 1 over 3 pi, 1 squared times 1 will give you 1 over 3 pi. 1 over 3 pi, if you want to find the total volume of the total shaded area, or the shaded volume, or the shaded region, so quarter pi plus 1 over 3 pi is equal to 7 over 12 pi. Last question from exercise 12e, page 284. Question number 5. The volume of the shaded area is in the form of A ln B. This is the equation of the curve. Find the values of A and B. So we know that volume, integration from A to B of y squared respecting to x. Limits from 1 to 2, squaring of 1 over square root of 2x minus 1, all to the power of 2 dx. So squaring of the 1 will give you 1, squaring of the square root d will cancel, so you have pi, integration from 1 to 2 of 1 over 2x minus 1 dx. Now you have to integrate that using the rule of the ln, because the power of the denominator is power 1 now. Derivative of the denominator is 2, but the 2 is not given. So you need to divide it by 2. Pi over 2, then ln modulus of 2x minus 1 from 1 to 2. Now once replace 2, ln 2 times 2 minus 1 minus ln 2 times 1 minus 1. So this is completely cancelled because it's ln 1. Pi over 2, ln of 2 times 2, 4 minus 1 is 3. So this is the value of A and this is the value of B cubic units. Thank you.